Today we're going to be looking at how to integrate using U-Substitution. It's probably one of the easier ways to integrate, but if you're finding it a little tricky, this is the video for you. And the first thing we're going to look at is this integral over here, the question 1. The integral of x times 2x minus 1 to the power of 4. And in general, anytime you do U-Sub, the first thing you want to do is just look at the more complicated thing inside of the problem. The more complicated thing inside of this problem is the 2x take 1. Now the 2x take 1 is what I'm going to be setting to be u, because it's just more complicated. So all I'm going to say is let the value of u, this is called u substitution, so I'm going to let u equal to 2x take 1. Now, there are two ways I can go about this. The first way is the way that I like to do it, and the first thing I like to do is I like to first differentiate this equation. And you might be thinking, why the hell are we differentiating? Can't I just let this be equal to u and that just makes life much easier? Well, there's this pesky little dx at the end of this integral. If I want to integrate this entire equation with respect to a new variable u, my current equation must reflect that. I don't want a dx over here, I want a du over here. And so all I'm going to do is I'm going to differentiate u with respect to x. So du over dx on the left hand side is simply equal to 2 on the right hand side. And now if I were to rearrange this equation, I want to replace the dx with du. So I want an equation that says what dx is in terms of du. So all I'm going to do is I'm going to do some algebra, bring the dx to the other side. So I'll be left with 2 dx equals to du. 2 times dx, all I did was multiply both sides by dx. And then I can divide both sides by 2. I can simply bring this to the other side. And what I'll be left with is dx is equal to du over 2. Fantastic. So now I'm going to write everything I have here, the u and the du and dx, sorry, not the du and dx, the u and the dx. I'm now going to replace the variables inside here accordingly. So what I'll have now is the integral of x times 2x take 1. Instead of 2x take 1, we're just going to say u to the power of 4 times by du over 2. Okay, so now we have an equation where it's in terms of u and not x. The next thing I'm going to recognize is there's an x over here. Why do I have an x? Didn't we just spend all this time trying to rearrange for u? So I should have done that at the start, but you'll know in the next couple of examples why I don't actually end up rearranging for x in the first step. So I'm going to do it now anyways. So now that I know I have to rearrange for x, I'm going to rearrange this equation to get something in terms of u. So if I rearrange this, I can say that 2x is equal to u plus 1. Therefore, x is equal to u plus 1 divided by 2. So now I have all three of my variables, and I can write that down. So now I have the integral of u plus 1 divided by 2, this is u, times by u to the power of 4, du over 2. Now you recognize it's du over 2 because that was what dx is. I'm just going to bring the half out to the front. So now I have this equation here. This is what I'm actually trying to integrate. So just to make life easy, I'm going to expand and simplify. So leave the half out the front. If I expand this, I get u to the power of 4 plus u to the power of 3. All I'm doing is expanding the u to the 4 here, u to the power of the 4 here. So it should be u to the power of 5, sorry, what am I saying? Divided by 2. And divided by 2, I always hate fractions inside. So all I do is I just factorize out the half that's inside the integral, and I bring it outside. So I'll be left with a quarter times by the integral of u to the power of 5 plus u to the power of 4. Now, if you have a look at this integral, this is much easier to integrate than the very first integral at the top. The first integral you had to either expand or it just didn't look nice. Now we can actually integrate this. So all the integral here becomes is the normal power rule. We can simply do a quarter times u to the power of 5 divided by 5, but then you add 1 to the power. So it's u to the power of 6 divided by 6 plus u to the power of 5 divided by 5 plus c, and all of this is times by a quarter first. So times a quarter plus c. And two things here. First, we do need to simplify out this half because it's not simplified. The second thing is we need to make sure that the u here is actually x, because the original question had x in it, so we can't just leave our final answer in terms of u. So we know that u is simply equal to 2x take 1. So I'm going to replace all of the u's in my final integral with 2x take 1. So if I were to fully simplify, I'll get 2x take 1 to the power of 6 divided by 24 plus 2x take 1 to the power of 5 divided by 20, because that's 5 times 4, plus c. And that is how you do u sub for this question over here. Alright, so now we have the next question over here, the integral of x times the square root of 1 minus x. And now we have two things to consider. The first thing we have is this x over here, and we also have the 1 minus x over here. And between these two, they're both pretty simplistic. I'd just say this one is more complicated, more confusing. So all I'm going to do is I'm going to say let u equal to 1 minus x. Okay, and I can already see that in the process of me having to rearrange and manipulate this equation, I'm going to need to replace this x with something else as well. So just using this equation over here, the u equals to 1 minus x, I'm going to rearrange and have x in terms of u. And if I rearrange it, I'll just have x equals to 1 minus u. Now what I can do is I can rearrange for the dx. And I can do that using this equation. I can do the implicit, in this case explicit differentiation. So the derivative of u with respect to x is equal to minus 1. Okay, and I want to rearrange for dx. That means that dx is simply equal to negative du. So here we go. Here are our three things that we would have to substitute into this equation. So our new equation, once we substitute all of this, will be the integral of 1 minus u, that's what the x was, I replaced that with 1 minus u, times by the square root of 1 minus x, or in this case, the square root of u. And I'm just going to write it as u to the power of a half. Times by negative du, but I can really just move this negative out to the front of the integral because it is a constant. So all I'll have is the negative at the front and this expression over here. Still look confusing? Not really. All you have to do is expand the u to the half inside the two terms in the bracket. So you have u to the power of half minus u to the power of 3 over 2, and I did that by simply making this u to the power of 1. Index laws says u to the power of 1 times u to the power of a half. You just add the indices together. And with respect to u, and this is very simple integration. All this happens now is you add 1 to the power, divide by the new power. So minus the integral of u to the power of, sorry, we don't need the integral anymore, minus u to the power of 3 over 2, you add 1 to the power, divide by 3 over 2, plus, and the reason I'm doing plus is because this negative times by the negative becomes positive, so plus u to the power of 5 over 2 divided by 5 over 2 plus c. And again, our original question had an x in the question, so we can't just simply create our final answer having a u just because we felt like it. We have to replace everything back with the expression that u equals to 1 minus x. So everything that has u in it, we simply go back and replace it with 1 minus x. So our final answer after simplification, oh yes, another thing, we can't have denominators and numerators be fractions. We do have to simplify this. So another way you can simplify this fraction is dividing by 3 over 2 is the same as timesing by 2 over 3. Okay, so all I can say is rather than dividing by 3 over 2, I'm going to say times by 2 divide by 3. Okay, and I can simply just eliminate all this. And this is my final answer. So plus, instead of writing divide by 5 on 2, I can write times 2 on 5. And that is the solution to this integral. Alright, another question that looks pretty similar. Pause the video and have a go first before I attempt it. Alright, I'm going to go through it now. So, obviously, the most complex thing that I can see over here in this equation is this x minus 1. So all I'm going to do is I'm going to say, you guessed it, let u equal to x minus 1. And I'll teach you a little trick. Rather than having to differentiate to find what dx is and say that du on dx is equal to 1, or 0 in this case, 1, and then having to rearrange, I'm simply going to do it implicitly. Implicit differentiation in this case, the derivative of u is 1, but then you chuck a du next to it, so that just equals du. And the derivative of x minus 1 is equal to 1 dx, just because we're differentiating the variable x. And that means the ones, you can just get rid of them. Du equals to dx. And another thing, we do not have to rearrange, we do not have to write an equation that rearranges x in terms of u. We do not need to do this here. And the reason for that is because in our original question, there's no other x's literally anywhere in this question. There's no other x's. So we can just simply keep it as write what u is and write what du is. And that's why I said in question 1, we don't always have to rearrange for x because some questions simply don't need it. So in this case, if I replace everything, all I'll have now is the integral of 1 over the square root of u du. And this is a pretty straightforward integral if I write it like this. The integral of u to the power of minus a half du, that is simply equal to add 1 to the power, u to the power of a half, divided by the new power, divide by a half, plus c. And again, we can use the property that dividing by a half is the same as timesing by 2 over 1, or simply just timesing by 2 in this case. So that means this integral simplifies to 2 times the square root of u plus c. Again, final answer, cannot have u, so replace the u with x take 1. So 2 times the square root of x minus 1 plus c. That is the integral of this problem over here. Alright, you know the drill. Pause the video, try it yourself, and I'm going to go through it now. So this one's a little bit more complicated because x take 1 and 2x plus 3, they're both, I guess, equally as complicated as each other. But this one is raised to the power of a 3, and anything that's more than what's necessary, i.e. doing a power, yeah, that's just annoying. So we're going to let that be equal to u. So in this case, between the x take 1 and the 2x plus 3, let u equal 2x plus 3. And now we can say that du is equal to 2 dx. That means that dx is equal to du divided by 2. And in this question, we do need to rearrange for x, because we can see over here, there's no way of eliminating that x any other way. So in this case, I'm going to rearrange and say that x is equal, I'll go slowly, you can say that 2x is equal to u take 3. That means x equals to u take 3 divided by 2. So there we go. We have everything that we need to substitute into this equation. We have u, we have what dx is, and we have what x is. So now, implementing everything here, we would get the integral of u take 3 divided by 2 take 1, that's what I did to replace this x over here, times by 2x plus 3, nope, u to the power of 3 dx. Not even dx, because we have times du on 2. Okay, so if I were to show using colors where everything goes, I can say that this x over here was what this over here was. This 2x plus 3 is simply just u, and the dx simply became the du over 2. Okay, so let's continue simplifying this equation now. I simply just don't like fractions inside integrals, so what I like doing is simplifying and bringing all the constants, scalar multiples, out the front of the integral. So integral of u take 3 take 2 on 2, that's how you simplify that bracket here, because 1 is the same as 2 divided by 2, and that times u to the power of 3 du. And the divide by 2, I'm just going to bring it out the front. Okay, and I'm also going to bring this divide by 2 out to the front as well. So what I'll have now inside here is u take 5, and the other divide by 2 becomes divide by 4 on the outside, because a half times a half equals to a quarter. Okay, so now I'm going to simplify the inside of this integral. 1 over 4 times by the integral of u to the power of 4 take 5u to the power of 3. That's just doing u to the power of 3 times u, and you can do that by saying u to the power of 1. And when you times two indices with the same base, you can just add the bases together to get 4. And then negative 5 times u to the power of 3 is minus 5u to the power of 3. Let's keep going. We can have the quarter out the front, and what we're left with is simply normal integration. U to the power of 5 divided by 5. Take 5u to the power of 4 divided by 4 plus c. And to replace the u, I'm going to use the fact that u was equal to 2x plus 3. And all our final answer will be is a quarter, 2x plus 3. So a quarter times by, in this case, I'm just going to times a quarter to everything. So what quarter times a fifth is 1 on 20. So 2x plus 3 divided by 5 times 4, and that's simply just times 20, to the power of 5 minus 5 times 2x plus 3 to the power of 4 divided by 4 times 4, which in this case is simply equal to 16, plus c. That is how you solve this problem here. Alright, next problem is this one over here, the integral of x squared divided by the square root of x take 2. Pause the video and give it a go yourself. Alright, let's try it now. So in this case, just a hunch, the x take 2 just looks a bit more confusing than the x squared because it's square roots. Who likes square roots, right? And square roots are just disgusting. So I'm going to let x equal to, sorry, not x, I'm going to let u equal to x take 2. Now that I have this, I can rearrange for dx. So I can say du is equal to dx. That makes our life very easy. And I also need something to replace this x squared with. So I'm going to say that x in this case is simply equal to u plus 2. And x squared then will be u plus 2 to the power of 2. So now that I have everything that I need, I can do the integral of u plus 2 to the power of 2, and I got this from saying x is equal to this. The integral of this is u plus 2 squared divided by the square root of u du, and the du came from here, so dx became du, and the square root u came from the x take 2. And let's keep going now. Now that we have this equation here, I can keep simplifying. I can say this is the same as the integral of u plus 2 to the power of 2 times by u to the power of negative a half du. Now, if you have a look at this question, it really doesn't look that nice, and that's because we have some random u plus 2 u squared shenanigans, and it just doesn't look nice. So the only thing I'm going to do here is I'm just going to expand everything out. So if I expand everything out, I can do the integral of u squared plus 4u plus 1, and this is simple binomial expansion, u plus 2, u plus 2, and then you can expand the u times u times 2, 2 times u, and 2 times 2. But I won't do that in this video here. Times by u to the power of negative a half du. Expand the u to the negative half to all of these terms. U to the power of 2 take a half. That simplifies down to 3 over 2. Plus 4u to the power of 1 minus a half. That becomes just a half. Plus 4 times u to the negative half. Can't really simplify that one. You have this. Now, it doesn't look that easy, but it is really just the same as normal integration. So this is the same thing as u to the power of add 1 to the power. So 1 plus 3 on 2. That's simply equal to 5 on 2. Divided by 5 on 2. But instead of saying divide by 5 on 2, you can remember from the previous question, that's the same as timesing by 2 on 5. So I can just say 2 on the top, 5 on the bottom. Plus 4 times u to the power of a half plus 1. That's the same as 3 on 2. And I'm going to use my same trick. Times it by 2 over 3. So if I times by 2 on the top, divide by 3 on the bottom. Plus 4u to the power of negative a half plus 1. Negative half plus 1 is simply a half. And divided by a half is simply the same as timesing by 2 over 1. Plus c. Now same step as before, replace the u with x take 2. Replace the u with x take 2 and simplify. So we have 2 times x take 2 to the power of 5 on 2 divided by 5 plus 4 times x take 2 to the power of 3 over 2 divided by 3. I forgot to times by the 2, so 4 times 2, 4 times 2 is 8, so I'm going to replace the 4 with 8. Plus 4 times 2 is also 8 in this equation. X take 2 to the power of a half. Divided by 1, I'm not going to write divided by 1, that's just the same thing. Plus c. This is your integral for this problem over here. Kind of messed up the box, but you get the idea. Okay, last but certainly not least, we have a definite integral to close it off. We have the integral of, from 0 to 2, of x times 2 take x to the power of 3. So pause the video, give it a go, and I'm going to go through it right now. So the more complicated thing is the 2 take x. So say it with me. Let u equal to 2 take x. And I'm going to write this as du equals to negative dx. Because the integral of this side is u, so it's just 1, and I just chucked a du because we're differentiating with respect to u. And on this side, the derivative of this equation is negative 1, and all I did was negative 1 times dx because we're differentiating with respect to x. And we got to keep going because this equation has this x that I want to eliminate somehow. So all I'm going to do is rearrange this equation for x in terms of u. And that would be x equals to 2 take u. And one more thing, because it's a definite integral, we also need to change the bounds. Now how do we do that here? So here's one way we can think about it. We know that this question here, we are talking about x values. We are integrating with respect to x. That means our bounds will be x equals to 0, and we can say our bounds are x equals 2. So if we currently have x values and we want to replace them with u values, I sure wish I had an equation where I can plug in my x values and out pops out values for u. Well, here we have it. So when x is equal to 0, we can say that u is equal to 2 minus 0, using this equation here, which is equal to 2. And when x is equal to 2, we can say that u equals to 2 minus 2, and that equals to 0. So that's what our new bounds are. Rather than integrating from 0 to 2, we're going to integrate from 2 to 0. So here we have it. Our new equation becomes the integral from 2 to 0 of 2 minus u times u to the power of 3 du. In fact, it's negative du, so times negative du. But you know, I just hate scalar multiples inside the integral, so I'm going to write du here and put a minus 1 out the front of the integral. And for this question here, we can use the property that the integral from a to b of f of x dx, if I were to just multiply this integral by -1, so if I have a negative at the front of it, that is the exact same thing as just swapping the boundaries, right? We can get rid of the negative and swap the boundaries, and it is equal to the same thing. These are both equal. So how can I apply that in this question over here? In this question over here, I can say that this is the same thing as the integral from 0 to 2, and we can get rid of the negative value, times by 2 take u to the power, 2 take u times u to the power of 3 du. Much better, because now we have ascending value of our integral powers. So let's keep going. This is the integral from 0 to 2 of 2u cubed minus u to the power of 4, and this is just u to the power of 1, so I added the indices together, du. Normal integration, this is the same thing. Because it's a definite integral, we do not do plus c, we simply just integrate as normal. So this is the same as 2 times u to the power of 4 divided by 4, and we simplify as we go. So 2 divided by 4, we can cancel these 2 to be left with a 2. So this is the same thing as u to the power of 4 divided by 2, minus u, we add 1 to the power, divide by the new power. So in this case, it's 5 is the new power. So u to the power of 5 divided by 5. And our bounds are from 0 to 2. Now, we in this case do not need to replace the u with whatever it was in terms of x. We do not need to replace it with 2 take x. The reason for that is a definite integral. This definite integral will simply lead us, it'll enable us to get a number. It'll get us a constant. Doesn't matter what u is, doesn't matter what x is, because this whole integral, this definite integral, is with respect to the variable of u, I'm going to get the same value, the same constant, regardless of if I integrated, replacing this u with x dx, or whether I replaced this integral with just the u and du. So there is no need to replace the u in this case, because I'm just going to get a number. So what will I have as my number? So to work out the definite integral, we substitute the top number into this equation first. So in this case, it's 2 to the power of 4 divided by 2 minus 2 to the power of 5 divided by 5. And then we minus away the substitution of 0, the bottom number, into this equation. So 0 to the power of 4 divided by 2 minus 0 to the power of 5 divided by 2. And those of you, divided by 5. And those of you who are astute in this recording will recognize that 0 to the power of 4 is simply 0, so this whole thing cancels out. And 0 to the power of 5 is 0, so this whole thing cancels out. That means the second half of this equation is kind of irrelevant. So let's keep going. 2 to the power of 4 is 16 divided by 2, minus 2 to the power of 5 is 32 divided by 5. And we want to obviously make this one fraction, so I'm going to multiply the left equation the left fraction, sorry, the top and bottom by 5, and the right fraction, the top and bottom by 2. So I'll be left with 16 times 5, and that is 80 divided by 10, minus 32 times 2 is 64 divided by 10. That equals to 16 divided by 10, which simplifies to 8 on 4, which simplifies, 8 on 5. That is our final integral of this recording. And if you have any questions, I will be making a part 2 of this video if it is needed. But just keep practicing the similar kind of problems. This is how U-substitution works. And let me know if you have any questions for the future.